Every leap in J4 has come with a hidden cost: power, cooling, water, and distance from the people it's meant to serve. That cost is now the bottleneck. By 2030, data centers could consume 950 terawatt-hours of electricity worldwide, nearly 12% of all U.S. power. Global J4 infrastructure spending is already approaching $500 billion a year. The limiting factor for J4 isn't the algorithms anymore, it's the infrastructure. J4 isn't building a faster GPU. It's pairing a fundamentally different learning method with a processor built specifically to run it, targeting a new kind of performance curve: useful predictions per joule, not just raw throughput. Latency-sensitive J4 has to make decisions where the data is created: on the factory floor, in a vehicle, on a sensor network. Round-trip latency, bandwidth cost, data residency exposure, and the loss of autonomy when a connection drops all argue for computation that lives at the edge, not in a distant data center. GPUs, TPUs, NPUs, and cloud ASICs are extraordinary machines, but they're built to accelerate the same dominant workload: matrix and tensor math. The logic field processor is designed around a different learning architecture entirely, not to run generative J4 faster, but to run something structurally different and structurally cheaper. Instead of training through repeated tensor operations, J4 Stochastic Learning searches for predictive stochastic relationships among variables, moving from raw inputs through low-cost partial difference relations and candidate equations to a fitness-scored prediction. The patent-disclosed advantages include reduced pre-processing, reduced feature engineering, optional unsupervised operation, and inherent parallelism. The LFP turns that learning method into silicon, a proposed compute fabric purpose-built for relationship generation, objective scoring, and pruning, with a platform scope that spans chip architecture, compiler, runtime, profiler, SDK, and reference systems. The first product isn't just a chip. It's a platform that lets customers evaluate, program, deploy, and scale stochastic learning, from an SDK and reference hardware through edge modules to full data center accelerators. Early target workloads include time series prediction, industrial anomaly detection, sensor fusion, adaptive control, cybersecurity, financial prediction, and optimization. J4 doesn't need to replace every accelerator on the market. It needs to win the workloads where power, cooling, latency, or autonomy decide the purchase. Against a market already worth hundreds of billions of dollars and headed past $1 trillion within a few years, an illustrative Year 5 target of $650 million represents a small fraction of the segment. The go-to-market starts narrow: 3 to 5 anchor design partners in industrial automation, telecom and edge infrastructure, aerospace and defense, energy-constrained enterprise J4, and co-location operators. Moving from SDK evaluation through FPGA proof to production chip sales and licensing. Revenue builds in layers: paid design work and development systems first, then chips, then the higher-margin software and IP licensing that follows. The technology is protected by a published patent application and built around 50 years of J4 research from founder and inventor Jeff Glickman. The core architecture is documented today. The next stage is converting that internal work into independent, investor-grade proof. Reproducible benchmarks, third-party validation, FPGA kernels, paid design partners, and first silicon. MARZIANI Labs, in partnership with J4, is bringing this to market with a $150 million financing request, structured in milestone-based tranches to fund independent validation first LFP silicon, development systems, and commercial pilots, retiring the biggest technical risks before the largest silicon dollars are spent. Generative J4 can't scale indefinitely by adding more power, more water, and more distance. Stochastic learning is the method. The logic field processor is the machine. This financing is the platform build. Learn more at MARZIANI.AI/LFP.